So how about another example? What about when the impurities are not eluted from the column? So let's say you have a poor mass balance, you get 10% degradation and you're only seeing a couple percent. How do you know whether or not things are getting stuck on the column that you don't know? One of the ways that if you're an old timer like me, you just get rid of the column and you take a look at the overall situation. You just take your undegraded sample and your degraded sample and get a UV spectrum of it. Here's an example of partially degraded sample, and you can see that this is the whole wavelength range from 200 to 300, well, in a UV sense. And you can see what is changing. So if you look at 40% degradation, you're losing a lot of this chromophore, right? And if you're at this wavelength, your total chromophoric response is the same. So you almost think about UV mass balance. It's a chromophoric mass balance. And I want to illustrate the idea. Here's a different case where we actually had this going on. It's what wavelength do you want to monitor at? Do you want to monitor at where there's an isospecific point so that you know the total amount of UV response you should get should be unchanging over time? If you look at monitoring in this case at 260, you've gone from an undegraded solution at 1.6 AU to a degraded solution at 1.2. So you would only expect to have 75% mass balance if you monitor at that wavelength, if everything comes off the column. If you had less than 75%, you know you're losing something on the column or you're not detecting it. So it's a little...